But please, let's welcome on stage Mr. Costa Tsaousis. Thank you.
Welcome.
Hey, Costa. How are you feeling? Okay, lovely. So are you ready to give your talk?
Yeah, of course.
Okay, so I'll leave it all to you. Go get it.
Wait, give me a second, guys, to fix that thing. Okay. So, guys, I am Costa. I am the founder of Netdata. Netdata is an open source monitoring solution. How many do you know Netdata? Oh, that's great. How many do you use? How many are you developers here? And how many? Great. How many operations? DevOps, SREs. Okay. Do you use other monitoring solutions? Prometheus? Someone? Great. Commercial ones? Dynatrace, Datadog? Okay. That's great. So, guys, to tell you the truth, this thing started because when I get pissed off, I write code. Others go to the gym. But for me, So in 2014, I was migrating some infrastructure from on-prem to the cloud. And everything was fine, but randomly, twice per month or so, we were having a lot of issues. So the entire infrastructure, it was a fintech, it was going in slow motion. No exceptions, no errors, everything worked, but everything was in slow motion. So after spending a couple of millions in monitoring, I built a team of 8 people. I bought every solution, monitoring solution that existed by that time. I had the impression that everything that I had built, these video walls and dashboards and everything I had built was just an illusion. It was just there to make me feel nice, but it couldn't detect anything. So I started thinking, OK, what is wrong? Why is like that? Why it's not real time? Why it doesn't have all the metrics? Why it cannot detect what is happening? Why it's slow? And I started building a monitoring solution. So the monitoring solution that I built was actually, my intention was not to build, it was an experimentation. So I didn't want to build a monitoring solution. What I wanted is to kill the console. So every time the infrastructure was slow, I had all my developers, 50 people or so, being all the systems, trying to figure out why it's slow. So I said, wait a moment, what if instead of having them on the consoles and this SSH to the servers and monitoring all the metrics that they need, can I build something to actually have the same fidelity, the same granularity, all the metrics and everything, and have a history also so that I can see what happened an hour ago? So I started building this tool. This tool is quite different from the traditional monitoring application. So this is an agent. You install it on your systems, but it's a monitoring in a box. So it has all the features. It collects metrics, stores metrics, learns the behavior of metrics with machine learning, checks the metrics with alerts. It has a query engine and a scoring engine, visualization. So everything, everything in an application. You install it on all your servers. To understand the difference, if you install it on an empty VM, you get an empty AWS VM, nothing there, just a Linux box. This is what you're going to get. You're going to get about 250 charts, 3,000 plus metrics, 50 unique alerts on 100 different components. You're going to get a system, a logs explorer, network explorer. You are going to have unsupervised anomaly detection everywhere. 2 years of retentions with 3 GB of disk space, and it will take about 1% CPU utilization and a little bit above 100 megabytes of RAM. Now, of course, if you use it, it's going to be like this. So these are your servers. You're going to have many dashboards, one on each server. Not very efficient. So we built this. So this allows you to put in a data. It's the same software. Here and there is the same software. You just configure this to stream there. And you have a parent. This is how we call it. And from the parent, you can have all the dashboards and the alert you need. Of course, this allows you to have multiple levels. So this is a grandparent now. A lot of parents and a grandparent. Now, we stress tested this solution against Prometheus. As you see, we are 1/3 less CPU, half the memory, 10% less bandwidth, almost no disk I/O compared to Prometheus. And the storage footprint is amazing. So you see, in Prometheus, we gave them 2.7 million metrics and 3 terabytes of storage. Prometheus managed to keep 7 days of retention with per second resolution. Netdata had 10 days of per second resolution, 43 days of per minute resolution, and more than a year of per hour resolution on the same 3 terabytes of storage. In December, University of Amsterdam, by themselves, they did an analysis to find the impact of monitoring solutions on Docker-based systems, on container-based systems. And they said Netdata is the most energy-efficient tool. Now, this is what happens in CNCF. Netdata is leading the observability category in CNCF. Of course, we're not incubating in CNCF. I didn't want it. The idea with CNCF is that they want, if you incubate, they want to control the roadmap of the project. But I didn't want that. So, but still, Netdata is the most loved, let's say, project in the observability category of CNCF. Now, you understand that if you build a monitoring solution like this, you have a few different kinds of problems. So the first is, OK, you install that thing. It detects your applications, your whatever you have. So you may have database servers or web servers or message brokers. It will detect everything. It will start collecting metrics. And actually, we don't filter metrics. We collect everything. If something exposes, even if it's a duplicate, even if it is, there are overlaps between the metrics. So everything, and everything in high resolution. Now, this thing presents automatic dashboards. The biggest problem was, OK, how do you build the dashboard? What is a dashboard that is built automatically? What, a list of metrics? Not very useful. So you need to somehow correlate the metrics. You need to somehow give meaning to them. So what we observed is that, you know what, of course, all our infrastructures are different. But wait a moment. We use the same VMs, the same operating systems, the same packaged applications. So a Postgres is a Postgres. Of course, yours has your own data. Mine has my own data. But the health of the Postgres server is the same. The monitoring of the Postgres server is the same. The same for every component. So disks, network interfaces, web servers, database servers, everything is almost the same. Of course, we built a Lego building. Each company has its own Lego building. But it's the same components. So the idea is that since we all have so much in common, can we come up with the rules to actually have fully automated visualization really out of the box? So this is what we did. We invented the Needle framework. The Needle framework says that, of course, there are metrics and they have labels, but labels have a meaning, have a scope. They are not all labels the same. So reads and writes, for example, you have disks. Reads and writes are dimensions, are not just labels. Or the type of the disk, or the serial number of the disk, or the model of the disk is something that defines the instance of that thing. So the idea is that we started aggregating things, structuring a data model in memory to come up with something that can be easily configurable from us, from the owners, from the developers of Netdata, in order to provide fully automated visualization. And we came up with this structure. So there is the context. The context allows us to say what the units of a chart or the attributes of a chart, or it's a container, let's say, that includes all the prototypes of how we build a chart. Okay? So all disk throughput charts have the same context. But then there are instances of that thing. So I have 5 disks. So I have 5 instances of it. So what we did is that we put all the dashboard information at the context level. We created alerts that are configured at the context level, but they are applied to instances. So you can say, hey, put this alert on all Samsung disks. Put this alert on all Postgres version 1.2, or on all Postgres. And the thing will do it by itself. Sorry. So this is another view in order to understand how the labels correlate with each other. So the instances have common label values, while the different instances have common label names. So all the disks, for example, have model. But the specific model is common on all the instances of one disk. So the result is that Netdata has fully automated visualization, so you just install it. You don't do anything else. You just install it. It has fully automated alerts. And we built, as we will see, the next challenge was how to come up, how to remove the query engine from the query language from that thing. How you can come up with a solution that is also point and click for visualization, for changing the visualization. No, so Netdata is a tool that can be installed even mid-crisis. So you have a problem, you don't have a monitoring, you install Netdata, alarms will fire up, it will tell you what is wrong by itself. The query language. Now, the query language is the most challenging thing of any monitoring solution. The biggest problem is the following. OK, you have a metric. How you can explain to people what this metric represents? Which sources contribute data to it? How much different dimensions it has? That's one challenge. And the second is, OK, what the guy wants. How he wants to visualize this. All monitoring solutions struggle with this. So what we did is the following. This is a data chart. It looks like a chart. Nothing fancy. There is an info button that tells you what the chart is, but this is where the fun begins. So the first thing is that there is an anomaly ribbon. This anomaly ribbon shows where anomalies are. This is from machine learning. The second thing is that we added this needle bar. We call this the needle bar. So this allows you to see immediately what happens with the chart. So it says this chart is coming from 7 nodes, 115 applications. It has 2 dimensions and 32 labels. And the fun part is that when you click this, you have all this information. So you can filter, you can see which instances, how many instances contribute to it, how many time series contribute to it. The volume, so 16% of this chart, of the volume of the chart, comes from Bangalore. The anomaly rate of each node, and the minimum, average, and maximum values of each node. Now, you understand that this is only for nodes. You can do the same for applications, for dimensions, for labels. So all the drop-downs have the same similar information. Then we said, OK, we solved the problem of slicing, so people can just click and slice on a label, or slice or filter on a dimension or an instance or whatever. How do we dice? How do we pivot? It's a cube, eh? How do you do this? And this is what we came up with. So you say, OK, this is the group by, the first menu. It shows you all the possible group bys. You can select as many as you want. And you say, OK, group by dimension, and then by device type. And you see here that device types are physical and virtual, and you see what happens here together. So the end result is this. Reads physical, reads virtual, virtual, writes physical, writes virtual. So you can slice and dice without a query engine from the UI. And it's pretty simple. Now, we also added this, it was before, this info ribbon. You see it? It's an info ribbon here. This info ribbon is this. Now, this shows that some of the dimensions do not have data. There may be other numbers, other annotations here, like a counter overflow, rounded up. So this is, do you remember my original problem, the infrastructure that was slowing down? Do you know what it was? So the cloud provider was doing maintenance on the VMs, on the hosts of the VMs. So they were freezing the VMs for small intervals. A second here, 2 seconds there, something like this. But it happened across the infrastructure, so the whole thing was going in slow motion. Netdata figured it out because of this, because it was missing data collection points. For most of the, if you go to Grafana just smooths the thing. So it connects the dots. All monitoring, actually, we're building a blog where we test Dynatrace, Datadog, Grafana Cloud, Instana, and Netdata. And what we found out is that only Netdata and Instana managed to detect freezes of the VMs. For all the others, you freeze the VM, nothing happens. You click play again, nothing. They just connect the dots. For Instana and Netdata, this is a gap. So this way, we managed to find bugs at the cloud provider side. And also, this allowed us to find top-of-rack switch issues on their networking equipment, again with Netdata. So what we accomplished here is that we managed to remove the need for a query language. This is the great success. No need for a query language. You just slice and dice all data on fully automated dashboards without learning anything. You just point and click. The next challenge was machine learning. Now, this is an interesting presentation from Google. It was in 19. So what they said, Google said, is that, you know what, we gathered all the SREs of Google, and we asked them, OK, what you want to achieve with machine learning? And they tried it. They put it on a lab and tried to do it. And they failed. Every idea was just a failure. just machine learning couldn't do what they wanted. So in the data, we try to do something different. The first thing is that we try to understand what can we get. OK, let's assume that we train machine learning models for all the metrics. Are they good? Can they be used for something? So in order for machine learning is noisy. So it has false positives. It says, oh, this is an outlier. No, it's not. But it's random. How you remove the noise? So we ended up, in order to remove the noise, we ended up training 18 different models, machine learning models, per metric. Now, once we had these 18 machine learning models, then we adapted the data collection engine. At the time it collects something, so per second, it goes there and says, OK, is this sample that I just collected an outlier for these 18 models that you have? And it takes a true or false. Yes, it is. No, it's not. All 18 models have to agree that something is an anomaly for Netdata to consider it an anomaly. What Netdata does then is that it stores this anomaly bit, just a bit. It stores it in the database. So together with the samples, you have anomaly bits. This allowed us to query anomalies. So you can go to the past and say, hey, you know what? Tell me the anomaly rate yesterday about this metric, from that time to that time. As the models were at that time, because the models shift. And what we do then is the following. This is what we noticed, guys. This is very interesting. So once we built this and we had all these anomalies, OK, we removed all the noise, and everything worked, then we realized the following. Anomalies happen in clusters. It's not just a metric. So the disk is slow, the throughput of the disk gets anomalous, the I/O operations of the disk get anomalous, the database server gets anomalous, the CPU goes down, so it gets anomalous, the network goes anomalous. And what we realized then is that, wait a moment, if you see this across the infrastructure, across multiple nodes, then it still happens in clusters. So one server gets anomalous, and moments later, another server gets anomalous, which is very interesting. So what we did there is that we created a node anomaly score. I think we said this. I will explain more. So a node level anomaly score, and we created also a tool, a special tool for that. So to understand how it works, this is a Netdata dashboard. Nothing fancy. There is a node selector at the top and several charts, one below the other, in sections. Here are all the sections. So at the press of the button, you press that AR button there. Netdata gives you the anomaly rate per section, so you can see where your anomalies are. This is for the time frame you are looking at. So if you go yesterday, this is about yesterday. I told you about the host anomaly rate. And this is how it looks. So we created this tool. This is a multi-node tool. It's a lot of nodes. And here is the percentage of metrics anomalous per node. Now look what happened here. One server is very anomalous. 10% of the metrics got anomalous. But look at the others, 5%. Look what happened there. One server influenced the other. Now, what we built with this tool is that you can highlight an area. You can say, OK, for this area, and Netdata gives you a sorted list of all the metrics across all the nodes. So the idea with this is that your aha moment should be in the first 20, 30 entries. So instead of speculating how troubleshooting happens for most monitoring systems, you speculate. You see the database server or you see the web server being slow, and you start saying, OK, let's assume that it is the database server. Go validate it. Oh, it's not. Let's assume it's the web server. Go validate it. Let's assume it's the DNS. Go validate it. What we change with this is to flip it. Instead of speculating, you press the button, you see a sorted list of what's anomalous, and the idea is that your aha moment should be there. What? The disks did that? The database did that? We flipped it. The good thing with Netdata is that this is unsupervised. So you don't need to do anything. It just works. It learns from the behavior of the metrics. You don't need to tell it what is good and what is bad, which is a great benefit. It just works. And it's another attribute of your metrics, of course. And it can detect node-wide or infrastructure-wide across the board. Next challenge. The next challenge, we delayed with this. We started working on logs this year, 23, last year. Logs is a beast. And we had built our own log management solution. But this summer, when I realized the beauty of systemd journal, I dropped our own logs management, and we switched to systemd journal. So let's see why. What makes systemd journal so unique? Systemd journal, the first, is everywhere. So you use it today, even if you don't know it, even if you are not aware that it is there, you use it today. The second is that the systemd journal is secure by design. So if you go to a compliance officer and you give him the specs of systemd journal, he will say, OK, we have it. That's it. It does the job. Is unique in which area? Most of the log management solutions struggle with cardinality. How many labels you're going to put? How many data sources you have? They struggle. What are you going to index? Systemd journal is the only logs management solution that doesn't care. So every log line can have its own unique fields with its own unique values. Every log line, which is amazing. It's the only system, as a developer, since you are developers here, imagine this. On every log line, you can put as much information you want to annotate it, the state, the internal state of the application, the source required that you were executing, whatever imaginable, you can just annotate it, the full stack if you want, the full stack of your application. OK, I reached that point, it's an error condition, take the full stack, take a dump of the data, take this, take that, doesn't matter. And the thing will index everything. Of course, it needs space, but it will index everything. Now, when I realized this, I said, wait a moment. This is unique. This is amazing. All people have it. It's secure by design. It's fault-tolerant by design. And it indexes everything. What else can you ask? So what we did is the following. This is the Netdata UI. This is how it looks. So it has all the fields, thousands probably of fields that you can filter with counters everywhere, full text search there, a chart with a distribution of the logs, etc. But look what happened. It is slow. Yes, it was. We submitted patch to systemd to make it 14 times faster. So we fixed it for systemd. The second is that it lacks integrations. How can I put an Nginx access file, access log into it? So we created all the tools to do it. So Netdata gives you all the tools to actually push your logs, your text file logs, JSON, log format, even extract fields from other text file logs, whatever, we created the tools to actually tail log and push everything into systemd journal. And the key weakness, of course, is storage. So you need more space, disk space, for this. But with this, I think that we accomplished another mission, to make logs easy and affordable for everyone. And this is the beauty of Netdata. Netdata, you install it, and you don't need to do much. Just use it. So focus on your job. Dashboards are there, alarms are there, logs are there, just use it. And this is the last challenge. Do I have time? I don't have time. Should I stop? I can skip this. Yeah. 3 minutes, OK. So the next challenge is about other stuff that we believe that are, observability is more than logs, the metrics, and traces. If you go, for example, to Datadog, they have an amazing process explorer and an amazing network explorer. These are neither of the others. It's not logs, it's not metrics, it's not traces. So in order to fix that and generalize this idea and make it powerful, we did the following. So every one of our plugins, so every node runs hundreds of plugins, of course, in order to collect data. So every plugin exposes functions. If it is a Postgres, it says, hey, I can give you a list of the slow queries. I can query Postgres. I'm connected to Postgres because I collect metrics. So I can get the list of slow queries and give them to you. So we started building functions, and we made the whole ecosystem to pass through. So you talk to a grandparent, and the grandparent will figure it out how to come there, ask for this information, get it back, give it to you on the dashboard. So this way, this is, for example, sockets. As you see, these are sockets. And we came up with a visualization that says public interface there, private there, clients and servers. And this is live. So you see the bubbles moving as the network changes. So, of course, we integrate it everywhere. The last slide, our monetization strategy. Everything is open source. You can use it for free. We have a SaaS offering that complements Netdata. So if we go a little bit back, oops, sorry, on this slide, there you can have Netdata Cloud, or here you can have Netdata Cloud. So you don't need to centralize metrics yourself. We can have a service that helps you accomplish that. So we monetize on there, role-based access and all this kind of stuff that people in businesses need. That's it. Thank you very much.
Yeah, thank you. If anyone has a question or two, we only have a few minutes left, like for a very quick review and very few questions. Ah, there is someone.
I will bring it.
Oh, he's running faster.
OK, there we have it. Sorry.
Hello. Thanks for the talk. Very interesting. I'm curious to understand how it can detect strange spikes when there is some kind of seasonalities. So I can think of a lot of applications that doesn't have a stable traffic during the day, but maybe has some peaks during the day, pitfall during the night. So it's able to identify this kind of events.
So what we are interested is about the transitions. It's a k-means model. It's not our code. It's the standard k-means model. What we do is that we feed 6 hours of data to it, so it learns the transitions. It understands that, OK, this metric can go from this value to that value, and then to that value, and then to the other value. So it can detect. There is a blog post on our site that describes the different kinds of detections that it can do. It can detect seasonality because it learns the transitions the metrics do. That from this value it can go there, and then there, and there. It can detect strange steps gaps, up or down, sudden up or down. It can detect that a metric that goes like this suddenly is flat. Oops. Again, this is not normal, because it goes like that all the time. So it's a standard algorithm, the way we do it. The 18 models that we do now, we train 6 hours. Every model has 6 hours of data, and we train one model every 3 hours. So it learns 2 days. It learns the last 2 days. It needs to forget, because it is unsupervised. If an anomaly happens, we want it to forget it after a couple of days. But now we are adding configurations so that you can say, hey, you know what, instead of 18 models of the last 2 days, I want models for Mondays, for Tuesdays, for Wednesdays. Or I want for the first day of the month. So allow people to configure this in order to be better for their patterns. Okay?
I think we have another question. We can take just another one, sorry.
Yeah, thanks for the talk. So I had a question about the needle framework and clustered applications. So if I have, for instance, a Cassandra, a distributed database with nodes running 2 different versions, I guess the dimension would be Cassandra and the label would be some version?
Yes, so if it is Kubernetes, for example, we collect a lot of labels from Kubernetes. What Netdata can do is that, look, it monitors every instance. So you have 5 Cassandras. OK, then every instance is monitored by itself. OK? But then what we do at the visualization level is that we can aggregate this stuff.
Yeah, that was the question. Essentially, if I have, like 10 pods or 20 pods for the same microservice, can I correlate metrics and logs throughout the whole global service using
that's
this
the
definition?
idea. Yes, yes.
And that could work at the parent level, I guess.
So
the
look how it works. At the parent level, the parent has a copy of all the data. So the children push the data to the parent. So the parent is autonomous. Okay? But then we had the problem that all monitorings have. How do you scale? OK, I give it to the parent the biggest machine possible, and still it's not enough. How do you scale? What we did then is we said, OK, on a data cloud, if you have multiple parents, or not parents, just independent servers, the data cloud can aggregate at runtime, at query time. So it will query the parents, get the responses, aggregate them to one uniform chart, and give it to you. You get it?
But if the pod is dead, I guess you still need a copy of the data because it won't be able to reach the node. But that's a separate question. Thank you very much.
Thank you. And if you need to continue with the questions, please do take Costa time for that. Because before you go away, I would like to give you this very wonderful trophy. Thank you for being
Thank you very much.
champion, Costa. And thank you for your speech. Big round of applause
Thank you,
for
guys.
Costa. Thank you. Thank you. So now it is